Welcome back to another lecture video. Today we're going to start with Chapter 10. And most commonly in this unit we're going to talk about reactions. So there's going to be some fun demos, some fun labs. I think you guys are really going to enjoy this unit. So we'll dive into the notes here. The notes are going to be split apart into four. So we have compounds and reactions first. We're just going to do some vocab with those. Then we're going to dive into some ionic compounds, as well as writing and naming those compounds. And then covalent compounds, writing and naming, and then lastly we're going to talk about some dot diagrams. Okay? So first things first, compounds and reactions. So let's just review really quick. What do we know about compounds as well as reactions? Now remember, a compound is a substance that's made by combining two or more elements, right? So I'm going to have an example here at the bottom, and those are multiple elements that are chemically combined, okay? So a chemical formula is multiple symbols with subscripts to show ratios of atoms in a compound. So if you look really carefully at this following example, it says, what is the ratio of atoms in this compound? So this compound right here is known as glucose, or C6H12O6. So we have this color-coded here where the letters are blue and then symbols. Remember, a chemical symbol is a letter, right? So C stands for carbon, H stands for hydrogen, and O stands for oxygen. Okay, notice that something else is color-coded here. We have this kind of maroon-purple color that is 6, 12, and 6. These are subscripts, and what they do is they show the ratios of the atoms in the compound. So in one glucose molecule, we have 6 carbons, 12 hydrogens, and then 6 oxygens. So if we walk through these questions really quick, what elements are in the compound? We said carbon, hydrogen, and oxygen. Then we said how many atoms of CH and O for one molecule of glucose. We said there are 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. So why do atoms combine? We understand valence electrons by this point, and we understand that they form bonds, but maybe we don't really understand why they do that. So what we're going to do is we're going to take some time to talk about why do atoms combine. And we mentioned it, but all atoms want to have a full valence shell. If you can't remember valence electrons, those are electrons that are found on the outermost ring. Okay? We're going to have some examples later on in these lecture videos as we keep rolling. So which group of elements has a full set of valence electrons? Take a second, maybe pause the video just to check in. It's group 18, the noble gases. They are going to have a full set of electrons. So would we expect them to make any bonds? We wouldn't. And the reason is because they have a full set, so they don't actually need to share their electrons. They're kind of selfish. That's why they're noble. So what is the number of valence electrons that atoms want to be happy? Typically, you're going to see that there are 8 valence electrons on the outermost ring. And so what we call that is we call that the octet rule. So now what I want you to do is take a look at this picture here. Okay? You guys are going to learn how to make these towards the end of this unit. And what I want you to pay attention to is carbon. Okay? How many valence electrons does carbon have? It has 4. Count the black dots. 1, 2, 3, and 4. How about oxygen? We know that there's 2 oxygens in this case, but we'll just pick this one over here. How many outer shell electrons? Well, 1, 2, 3, 4, 5, and 6. Notice how it's the exact same on this side. Now, if you're wondering, this is a perfect example of what is called the octet rule. Okay? Atoms, other than the noble gases, because we said the noble gases aren't going to form any bonds, need to react or combine to get 8 valence electrons. So in other words, atoms must work together to fill each other's valence shells. Let's go back to this example here. So carbon. Okay, carbon, if you look at carbon's oxidation number, that's a vocab word. We're going to bring that back up here in a couple minutes. If you look at carbon's oxidation number, it's a plus or minus 4. In other words, carbon is either going to donate 4 electrons or receive 4 electrons. Now, take a look at oxygen. Oxygen, how many electrons does oxygen need to be stable? It only needs 2. So if you count the dots here, okay, let's count them again. 1, 2, 3, 4, 5, 6. What do you think happens between oxygen and carbon here? Oxygen is actually going to share carbon's electron. So if you count, for each one of these atoms, we should get to 8. So 1, 2, 3, 4, 5, 6, 7, 8. Oxygen is stable. Let's count carbon. 1, 2, 3, 4, 5, 6, 7, 8. Carbon is stable. Let's count this oxygen. 1, 2, 3, 4, 5, 6, 7, and 8. So the way that elements are able to obtain their full shell is by forming a bond. In this case, carbon, which is a nonmetal, and 2 oxygens, which are nonmetals, they're going to form a covalent bond, or they're going to share electrons. We're going to talk about that later, okay? But if you don't know what this compound is, this is actually carbon dioxide. For every 1 carbon, I have 2 oxygens. So the chemical formula for this is CO2. Take a look at this sodium and chlorine. Okay, sodium is a metal, chlorine is a nonmetal. Okay, we have them labeled here. The outer shell electron for sodium is the X, and chlorine has dots. Sodium has 1 outer shell electron, chlorine has 7 valence electrons. So, why do atoms combine? We said that atoms must work together to fill each other's valence shells. In other words, they're going to form bonds with one another. So, take a look at sodium and chlorine. We talked about how many valence electrons each one has. Okay, sodium, we said, has how many? 1. How many does chlorine have? 7. So, can these two combine? And if we can, how does this happen? The answer is yes, absolutely. Sodium is going to donate its electron to chlorine. So this X actually, through a reaction, gets added to chlorine. So, using what we know from last unit, sodium, if it donates an electron, is going to become positively charged. That's what it's telling you here. Chlorine, which receives an electron, remember an electron is a negative particle, so if we receive 1 more electron, that whole chlorine is going to become negatively charged. Okay? And that's what I just explained here. So when these atoms combine, sodium will become a positively charged atom, and chlorine will become a negatively charged atom. Okay, so here's the chemical reaction that we use in chemistry. You guys are going to learn this later. And that's all we're going to talk about for today. So hopefully that was just a nice, easy review for you. We're going to come back to ionic compounds in the next video, but I hope that this was helpful.